You're doing that. I will go ahead and introduce us. So, hey
Yeah.
guys, thank you so much for joining us tonight. We're excited to be here. My name is Kristin Luthi, and I am the science instructional coach for Gwinnett County Public Schools, and I also support elementary school computer science and elementary school AI in Gwinnett County.
Thanks, Kristin. I'm Sallie Holloway. I also work in Gwinnett County. I work in the CTE office, and I support all of our computer science and engineering programs across the district. And like Kristin, we're working on all of our CS and AI initiatives together. So we are excited to have you here. Today, we're going to be looking at binary bracelets and talking about some of the flexibility that you have in doing this lesson, but I think what I love about this lesson is you don't have to know anything about binary yourself. It's definitely something that a teacher who doesn't really have a CS background could pick up and run with. You don't get very deep into the concept. It's really an introductory lesson into just what binary even means, and it's a kind of a fun hands-on activity for kids to get engaged and get excited about the idea. I think that this is a lesson that could be done, in a special CS Ed Week activity with just any group of kids, but even in a CS class as an introduction to binary, if that's something that you're going to be teaching. Kristin and I are actually going to be doing this lesson with a group of students in a few weeks, and we are making little kits that we're going to mail home to them just in a regular envelope because this is all very small, and they're going to be able to follow along with us at home while we're in Zoom using the kits that we have for them. But there's also some other accommodations that we'll talk about if sending a kit home is not an option for you, some ways that you could still teach this lesson. So there are two big goals for this. One, just an introductory, exploring how computers store data using binary digits, just to help students understand that computers don't use the same language that we do, and they get a little bit of a better understanding as to how that data is stored and read. And then, of course, we're going to teach them how to encode a letter into binary. So they're going to get to do that with their own initials. I did include this in here. I'm not going to read it to you, but as you come back to this, we did include the standards alignment for this activity in case that's something that you would need at your local school. So in this activity, students are going to learn a little bit about binary code. They're going to explore how data is translated. Then they're actually going to get to translate their initial into code and create a bracelet or a keychain or really a necklace, anything that you would want them to use beads to create, they could do in this activity. So the materials are pretty cheap and simple. If you're doing the bracelets, it's really just string and at least 2 different color beads. And between the two, they need 16 beads total if you're just doing one letter. I'm sorry, they need 8 beads total if you're just doing one letter, one initial. You also have the option to do this on paper. If you have like markers, colored pencils, crayons, anything like that. There's some additional resources at the end that you'll have access to that can help you with that. So this is where we actually start the lesson. So when we give this lesson, when you would use this with your students, I always like to start by getting them to connect what they already know to what we're going to talk about today. So how do computers store information? So have your students think about what types of information, as we call data, do our computers store? You might have to prompt them a little bit to think about their phones or their tablets or their computers and kind of what are the different things that you're looking at. You're looking at videos, you're playing games, you're typing in a Word doc, all of those different things. That's information to a computer. And then explaining that computers actually speak their own language. So kind of just like we all speak a language or multiple languages, computers have their own language. And when we need a computer to read and store certain information, it has to be translated into that computer's language, which is called binary. So this is, again, just trying to get them to connect what they know to what they're going to learn about today. So here's a little bit of a definition for them on binary code. Binary is a way of representing information using only two options, those being a 0 and a 1. So explaining to your students that in binary, there are no other characters. All that complex data, all those videos and images and games that they use eventually get translated into zeros and ones for the computer to understand. And then helping them understand that letters can also be translated into binary code, which is, of course, what we're going to be looking at in the lesson with them. This is a short 2-minute video. I am going to play it for you here just so you can get an idea, but it kind of explains and has some visuals on binary code that might help your students understand it a little bit better. And Kristin, you'll have to let me know if you can't hear it. I think we've got that setting checked.
Throughout history, almost every civilization has used a decimal number system with 10 digits, 0 through 9. All of the numbers we can possibly think of use some combination of those 10 digits. Computers, however, operate very differently. Instead, they use a number system that has just 2 digits, 1 and 0. This system is called binary, and your computer uses it all the time. Computers need information in order to do what they do. This digital information, or data, is made up of something called bits. Bit is short for binary digit, meaning each bit is really just a single number, either a 1 or a 0. These bits can be combined to create larger units like bytes, megabytes, and so on that we use to measure our files. The larger a file is, the more bits it has. So something like a high-resolution video is actually made up of millions and millions and millions of ones and zeros. So how exactly do these ones and zeros come together and allow a computer to function? Let's think of binary as a light switch. Imagine that a 1 represents the light switch being on, and 0 represents it being off. With binary, the light is either on or off with no other possible states. So these bits are strung together as different combinations of 1s and 0s, and they form a kind of code. Your computer then rapidly processes this code and translates it into data, telling it what to do. You might be wondering, why do computers use binary instead of the decimal system that we use for counting things in the real world? Well, as previously mentioned, binary has 2 states, off and on. If computers were to use decimal, there would be 10 states instead. Our computers would have to work a lot harder to process all of these. Binary is easier for them to process and also takes up less space. Just like atoms make up everything around us in the real world, everything in the digital world, including video, text, pictures, and more, can be broken down into binary. And even though we can't see them, it's all a bunch of 1s and 0s.
GCF Global. Create.
So anytime I do a video with kids, I always kind of like to check for understanding after that. So there are a couple questions here just to help you with that. And you could keep it just as simple as these 3 questions. Kind of, what is a bit? Where do the terms like megabyte, terabyte come from? And how are these files stored? If you're actually teaching this in a CS class, of course, you could go a little deeper and reference more of the learning that was in that video. But this is just a good for this activity, kind of surface level understanding of what the video was explaining to them. The next thing I would do with my students is practice a little bit with them. So Kristin is going to put a link in the chat to a binary decoder key. And so you kind of can, maybe jog your students' interest and talk about how we're going to create a secret code using binary. They're going to get the key. But it's really just each letter already translated in that binary code. And so this is what I was talking about, why you don't really have to know binary yourself, or your kids are not going to be asked to truly go in and convert binary on their own. But just so they're at least seeing what that looks like is a good introduction to the concept. So I would ask my kids to, this is letter A, this is what it looks like. What is turned on, hopefully kind of helping them understand that the 1, the yellow, is on, and the 0, those gray boxes, are off. So then I would do a little practice with them. let's see if they understand it. So let's do this together right now. Hopefully you have been able to access the decoder key in the chat. So take a moment and see if you can figure out just this first one here. What letter is that?
And once you have it, you can put it in the chat box and we will check your answer.
Yes.
We have N as a guess.
Anyone else? Give you about 10 seconds to see if you can find it. Too bad we're not in person to give out some like leftover Halloween candy or something to the right answer. But Megan, good job. That is correct. It is N. And so just so you know, if you want to take the slide deck when we're done, we'll share it with you. But this is something that all the answers are in the notes. So if you kind of, weren't really sure yourself, of course, you could reference that. So let's try the next one. It's a little more difficult. We're going to look at each of these 3 letters, and these 3 letters spell a word. So let's see who can be the first one to figure out what word this spells.
I feel like we need some Jeopardy music.
I know. Some good wake time music. All right, we'll give you about 10 more seconds, and then we'll move on for it. Great job, Megan, our star student today. That is correct. It's cat. So this is just something small. Of course, you could keep adding if you wanted to play around with your students. This slide is in here as well if you kind of want to take it a step further. We're not going to ask you to decode this right now, but this is in some of that code.org resources as an example that we'll share with you at the end. But this spells out code is fun. So you could do all sorts of fun little decoder activities with your kids leading up to putting their bracelets or their keychains together. So before I cut my kids loose to actually do the hands-on part, I kind of want to make sure that they understand it, right? They can kind of do it on their own. So I would ask them to write out their initial first. So this could be something if they're at home and they couldn't print out like a worksheet or anything like that, where maybe you had them draw these 8 boxes in this way and they could color in with their pencil or something, what's on, but some way for them to write down whatever their initial is in binary code. And again, they get to use that decoder key. They don't have to do it. If this is something that you've been teaching though already, and you do want your kids to translate on their own, of course you could take out that decoder key, and this could be an even more rigorous challenge for them to try to figure it out without that key. So that's an option as well. And then the fun really starts. I love getting hands-on with CS. I think it's always something different for the kids to experience. So you will need a color that represents the 0 and a color that represents the 1, and make sure that the kids have enough of each so that they can put their bracelets together. Again, if they're not having access to the kits or to beads or anything like that, code.org actually has like a paper bracelet they could cut out, tape it. You could do something simple like that, or make like a sign for their room. I mean, I've seen so many different things where kids are just kind of getting creative and putting things into binary. If you want to extend this out even more, they could do more than just their first initial. You could have them even code their full name. I recommend if you do that you have a third color so you could separate between each letter, maybe even get smaller beads so that it fits well. But there's a lot of things you could do. You could even have them do some secret messages and give the gift to someone else. So I think kids enjoy this and have a lot of fun with it. This is something I'm not going to click on these links, but just know that they will be available to you. But there are several different activities out there on binary bracelets with different ideas and resources to help you with that. And then if you are teaching binary, if you want to go beyond this little mini lesson, Crash Course has a great video on using binary to represent numbers and letters. So that's definitely something that you could do to learn at a little bit deeper level about what binary does and how it works. So Kristin has put the link to the presentation in the chat so that you have access to it. I know that Constellations is also going to share this recording and any resources with you all afterwards as well. This is actually a pretty short session. It's a simple activity that you can pick up and go. So we're done early. Kristin and I will stick around for a minute if you have any questions, but otherwise you may actually have time to go jump into another session and hear another idea. So thanks for your time. We hope that you have some ideas for CS Ed Week, and we can't wait to hear about them. So if you have questions, send them in the chat. Otherwise, go have fun and learn something in another session.
And come back for AI.
Yes.
The third session.
Yes.
Thanks, guys.
Thank you.
Natalie, we just finished up, but I put the slideshow in the chat feature if you would like it. So Megan has a question about using this for little friends, and I was thinking about that fourth grade standard where students have to create a device to communicate across a distance. And I was thinking how it would be great to integrate it into science and have them create something, a code in binary code, and have them maybe present it across a distance, maybe like in posters or something, and then having kids across the room try to figure it out. So that would definitely work for those little kids. And I think the more exposure that we get to coding, the better. So yes, absolutely. I was telling Sallie this morning, my daughter's tablet is out of memory, out of space. And she was like, why can't I download any more apps? And so I said, if you really want to know why. And so I went into binary code with her, and she was not as impressed. She's in second grade, but yes, definitely for little friends too.
Yeah. I mean, it's basically an arts and crafts project means computer science. So even if you don't go quite as detailed into what binary really means, I think it would be fun for them.
And we love those crash course videos. They are great.
Yeah, especially for middle school, even some upper elementary.
Yep.
Anything else? All right. Kristin, let's see. I think he wants to get a shot of our presentation here. Yes, Megan, this would definitely count as an hour of code activity. This would be that, and that's exactly what we designed it. We know hour of code looks very different, for each school and how they implement it. And it's not technically coding, but the whole goal is just to get kids exposed to CS. So if this is an activity that would be doable for you and you think might build that interest, 100% you could do that.
And we bought, I know Sallie said at the beginning, we are presenting this for the community-based mentor program in Gwinnett County. And so we literally bought the materials from Amazon. They have bags of 900 beads, and they're like, some of them were like $6 or $7 for 900 beads. And then we just bought the string. So very reasonable. And like Sallie said, just to get the kids excited. And you can do keychains too. Like if your boys don't want to make a bracelet, we bought little key rings so they can make a binary keychain. So anything like that is awesome.
Yeah. And I know it's not feasible for everyone to mail these home, and that depends on budget and time and how many kids. But if that's something that you think your school would support and could be able to do, it's great. You know, I'm sure right now, especially kids love getting mail in general. I'm an adult, and sometimes I like getting mail. It's not a bill, but you know, I think it just might add a little bit more magic to it for your kids to know that they got, you know, something, a kit from you, and they're going to get to build it together. And so I think it could be fun. Anything else?
Thanks, Megan. We appreciate you.
Yeah, thanks. Well, thanks for joining us today, you all. Hope you've got some time to go check something else out. And hopefully maybe we'll see you for our last session later on. Have a good night.
Do we click leave?
Let me check and see if PV got what he needed.
Is he going to tag me in it? Use AI? Tag a friend?
Yeah, he got it. He got it. Okay. All right. We're leaving.